in question 4, we're given data on how much 30 different households spent on video rentals during 2005. So for example, one family spent $6 on video rentals that year. Another family spent $111. We can see two families spent $405 and so on. So the main purpose of this question is we want to create a histogram and then interpret it. Now, remembering what a histogram is, a histogram sort of looks like a bar chart. It allows us to visualize the distribution. In other words, it allows us to visualize this data set right here. And so our histogram consists of a bunch of classes or groups. So in other words, this could be families who spent between $0 to $50. This could be families who spent $51 to $100 and so on. 101 to 150 here. And then the height of each bar would represent how many families there were in each group. So for example, I could say perhaps 10 families spent between $0 and $50, 20 spent between 51 and 100, and so on. That's just an example. So let's create a histogram for this data set right here. Now if we want to be exact, we can use a formula called Sturge's formula to figure out how many different classes or bars we should have on our histogram. So let's go ahead and do that. So Sturge's formula says that the number of classes or the number of bars on our histogram is equal to 1 plus 3.3 times the log of n, where n here is our sample size. So our sample size, we're told, is 30. There were 30 households. So we should calculate 1 plus 3.3 times the log of 30. This is the log base 10, by the way. So if I plug this into my calculator, I get 5.87. So in other words, does this mean that I should have 5.87 bars on my histogram? Well, that doesn't quite make sense, because how do I do that last 0.87th of a bar, right? So anytime we use Sturge's rule, we always want to round up to the nearest or to the next integer. We always want to round up. So in other words, we should have 6 classes. Okay, so now we want to figure out what the width for each class should be. In other words, what intervals should we have? So we have a formula for this, and this says that the class width is equal to the maximum value in our data set minus the minimum value in our data set divided by our number of classes. So let's look at our data. All of these data points are in order quite conveniently, so we can see pretty easily that our minimum in our data set is 6 and our maximum is $808. So our class width is 808 minus 6, and we found from Sturge's formula that our number of classes is 6. If I plug this into my calculator, I get 133.37. So this means, for example, my first class on my histogram should be from 6 to 103, oops, not 203, to 103.37. But in general, to make it easy on ourselves to calculate the intervals, we also want to round this up. So let's round this. So our class width is 134. And always, we like to start our classes at the minimum value in our data set. So our starting point is 6. You could also, there's another convention, you could also use one less than our minimum. So instead of starting at 6, we could also start at 5. Up to you. I'm going to stick with 6. Okay, so now in part B, we want to find our class boundaries. We want to make our classes. And then we want to find our class midpoints. Okay, so our starting point is 6. So my first interval, or my first class, will start at 6. And we'll go to 6 plus 134. In other words, 140. The key point here when we're making our classes is that our intervals include our lower bound, but exclude our upper bound. So that's why I use this notation. So the parentheses here means this interval does not include 140, but the square bracket means that this interval includes 6. What exactly do I mean by that? Well, I mean that 140 is not in this interval. This interval includes everything including 6 to 139.99999. So basically everything from 6 up to, but not including 140. And the reason for that is because we're going to start our next interval at 140. And we don't want 140 to show up in both of these groups because we don't want to double count it. So our next interval will start at 140, go to 140 plus 134, our class width. And what does that equal? This equals 274. And again, I'm going to exclude 274 from this one and include it in our second class. And remember, we determined that we were going to do 6 classes. So 274 plus 134. Which is 408. Next one starts at 408 and goes to 542. 542 to 676. So class 4, class 5. And then our last class will start at 676 and go up to 810. And you'll notice that these 6 classes cover our minimum value and cover our maximum value, which was 808. And so if you use Sturge's rule and you use this rule, this formula for the class width, you will always create good intervals that will cover your entire data set. Okay, so next, our next task for part B is to calculate the midpoint of each interval. To calculate the midpoint of any interval, you take the upper bound minus the lower bound, plus the lower bound, and divide by 2. So the midpoint for our first class will be 140 plus 6 divided by 2, which is 146 divided by 2, it should be 73. And so on. My midpoint here would be 274 plus 140 divided by 2, and so on. Okay, so now we want to construct a relative frequency table using our classes. So I'm going to copy my classes again. And I'll use these to make our relative frequency table. So these will be my classes. First, I'll calculate the absolute frequency, and then I will calculate the relative frequency. This will make it a little easier on me. Okay, now how do we calculate frequency? Well, all I want to do is count up how many data points are in each interval. So first, let's take our first interval from 6 up to but not including 140. So I see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 data points in my first interval. Now I want to look from 140 to 274. How many data points are there? That's 1, 2, 3, 4, 5. So there's 5 data points in class 2. In class 3, from 274 to 408, 1, 2, 3, 4. From 408 to 542, look at that, there's actually 0 data points in that interval. From 542 to 676, there's 1, 2. And from 676 to 810, 1, 2. So now I have my absolute frequencies, so now I can calculate the relative frequency. Remember, to calculate relative frequency, I simply take the total count, or the count, and then divide by the total number of data points in my set. Remember, we studied 30 households, so there's 30 data points. If you count up all of these, you'll get 30. You can also just believe the problem when it says there's 30 households. This relative frequency is 5 over 30. This is 4 over 30. 0, 2 out of 30, 2 out of 30. I'm going to convert these to decimals. So this should be roughly 0.57, 0.17, 0.13, 0.067, 0.067. Now we can get to the fun part, part D, where we construct our histogram. So this part is actually quite simple. I'm just going to draw my axes. My y-axis will be the relative frequency. You could also just do the absolute frequencies, but since we went to the trouble of calculating these relative frequencies, I'll do that on my y-axis. And this will be household spending on videos, video rentals. And then, let's see, I will do ticks 0.1, 0.2, 0.3, 0.4. All right. So now, all I need to do is graph each class. So I'll take my first class, 6 up to, but not including 140. So this is my first bar. This relative frequency was 0.57. It's about yay high. This class was 6 to, say, 139 inclusive. My next class is from 140 to 274 exclusive. So in other words, from 140 to 273. And that relative frequency was 0.17. So that bar will be about this high. My next class, 274 to 407 inclusive, and that was 0.13. My next class, 408 to 541 inclusive, was 0. And then 542 to 675 inclusive was 0.067. And then same for my last class. Which was from 676 to 809 inclusive. This was the same height, 0.067. And that is my histogram. I've spaced out these bars here, just put some space in between them, just to make it a little easier to read, but you can put the bars right jutting up next to each other. Okay, so now let's use our histogram to answer these questions. So our first question asks, acting as if the only information we have was the histogram, in other words, assuming that we don't have the original data set anymore, what's the estimated percentage of households that spent at least 140 on video rentals? At least 140 is asking for who spent $140 or more. So that's these bars. So since I have the relative frequencies, I can just add up these percentages. So this is 17% plus 13% plus 0.067. Oops. Why don't I round these up to 7? 7% plus 7%. If I plug that into my calculator, I should get about 44%, give or take some for rounding. Next, what's the estimated percentage of households that spent less than $408? So strictly less than $408 is everyone who spent 407 or less. So that's these 3 bars. Less than 408. So I can add up these percentages, which is 57% plus 17% plus 13%. And if I do that, I should get 87%. So that tells me that 87% of the people on our data set spent less than $408 on video rentals. Last, this is a two-parter. First, we want to know what's the estimated percentage of households that spent at most $274. This one is a little tricky. The wording is very important to be careful about. At most 274 means we want people who spent $274 or less than that. This one we actually cannot figure out just looking at our histogram, because just looking at our histogram, we don't know how many people spent exactly 274. All we know is people who spent strictly less than 274. That's these two bars. This bar right here gives us the people who spent $274, $275, $276, all the way up through $407. So just looking at this bar, we don't know how many of this 13% spent exactly $274. So we can't answer who spent $274 or less, or in other words, who spent at most $274. So this one we cannot answer just by looking at the histogram. We can only answer who spent strictly less than 274, not at most 274, because that includes that upper bound. Okay, now for the last part, we want to answer who spent at most $300. Let's go back and look at our histogram. At most $300, so in other words, $300 or less. The problem again is this interval right here. If we want to know who spent $300 or less, well, that's a problem because, again, we don't know what proportion of the 13% of this 13% spent $300, or between $274 and $300. We can only answer who spent $407 or less, or who spent less than $274. So because 300 is in the middle of this bar, cannot answer this question.